Alright, so up until now we've been primarily talking about motion, and now we're going to talk about a new topic called force, okay, and what a force is. So what is a force? Well, a force is essentially a push or a pull. When something is pushing against you, that's a force. When something is pulling you, that's a force. A push or a pull. Now, just like velocity, remember we measured that in meters per second, okay? Just like velocity, how velocity has a unit it's measured in, force also has a unit, okay? And force is measured in newtons. And newtons are abbreviated with a capital N. Force is measured in newtons. So here are some examples when force is occurring, okay? So when we're sitting there and you're doing your schoolwork and your pen or pencil is taking notes, kind of like I'm doing here, just drawing this squiggly line, my hand is actually adding force to the pen or pencil in order to make that line. I'm adding force to press down, I'm adding force to move the pen towards the right. There's forces acting on that. Also with this example right here, okay, this is a picture of a bulldozer. Okay, if you take a look here, there's some forces acting on this. The bulldozer is moving the dirt. There's force from the bulldozer moving the dirt. Now, I want to make something very clear here. Adding a force doesn't necessarily mean there's going to be motion. For example, if you're sitting in a chair right now, the chair's not moving, you're not moving. You are the force pressing down on the chair. But there's also a force, so if here's our wonderful chair, okay, and you'll just have to forgive the fact that I can't draw. There's 4 legs, okay? And you're sitting in the chair, right? And your legs are off to the side, and here's your feet, okay? And you got your arms, okay? And you're sitting there in the chair. You are a force pressing down on the chair. But at the exact same time, the floor that you're sitting on is also pushing up on the chair, which is why there's no motion, because this force pushing down is the same as this force pushing up. So let's say, for example, the force pushing down on the chair was 10 newtons. The force pushing up on the chair is also 10 newtons. So now with this, the 10 newtons pushing down and the 10 newtons pushing up, we actually have a new term here, and this is called net force. And the net force here in this case is 0 newtons. Okay, because the 10 newtons down and the 10 newtons up, they cancel. Okay. Now, force is a vector. Now, you should remember from our last unit when we were talking about vectors, vectors have magnitude and direction. So they have a size and they go in a direction. Force has a size. For example, this is 10 newtons, that's the size, and the direction is downwards. This is 10 newtons, which is the size or the magnitude. Magnitude and size are the same thing. 10 newtons is the size, magnitude, and upwards is the direction. So force is a vector, has size and direction. So now that we know net force is the combination of all the forces acting on an object. So let's go ahead and write that down as a word to know, and that's net force. Okay, is the combination combination of all forces acting on an object. So let's go ahead and let's look at this example right here. Here we have a piano. I'll make this a little bit bigger. We got two movers moving a piano, okay? And let's say that one person is pushing. So let's say that this person right here on the right is pushing in this direction. And let's say they're using a force of 25 newtons, okay? And this person is pulling in this direction. And they're pulling with a force of 20 newtons. We can calculate the net force. We have two arrows going in the same direction. We're going to add them up. We're going to add up this vector and this vector. And can do that. 20 newtons plus 25 newtons equals 45 newtons. Now, that's just the magnitude, okay? We also have to have, I'm going to erase this arrow right here, okay, it's getting into the way. We also have to have, not only just we have to have a magnitude, we also have to have a direction. 45 newtons, what direction? To the left. To the left. Okay? 45 newtons to the left. That is the net force. We have two forces acting on this piano. We have the one that's being pushed by this guy here, and the one that's being pulled by this guy here. Two forces, but they're going in the same direction. So that's the net force, 45 newtons to the left. Alright, so let's go ahead and let's do another example here. Here we have two dogs. Okay, I'll zoom that up there for you. Two dogs, and let's consider that this larger dog, they're obviously playing tug of war. This larger dog, let's say that this dog here is pulling in this direction at, let's just say 15 newtons. Okay, and this dog is obviously pulling in this direction. Let's say the smaller dog is pulling in 12 newtons. Okay, what is the net force? Okay, so that's the question. What is the net force? Go ahead and spend just a minute calculating that out, and we'll go over it together in just a moment. Okay, so we have 15 newtons to the right, 12 newtons to the left. Okay, that is a difference of 15 newtons minus 12 newtons. Total of 3 newtons. So the net force is 3 newtons. But remember, force is a magnitude and a direction. So it's 3 newtons in what direction? It's 3 newtons to the right. That is how you calculate net force. Okay? Alright, so with net force out of the way, let's move on to talking about two different types of forces. We have balanced and unbalanced. Okay? Whenever you have a balanced force right here, balanced and unbalanced. Whenever you have a balanced force, there is no motion. No motion whatsoever with a balanced force. Okay? If you go back just a little ways, we had that example of oh, we didn't have that example. I apologize. If we had tug of war, for example, we had person A over here and person B over here, and they were playing tug of war, and person A was obviously pulling this way at 15 newtons, and person B was pulling this way at 15 newtons. Okay, there's going to be no motion of this rope here in the center. No motion at all, because they're pulling at equal force. Equal force or a balanced force means no motion. Okay, much like sitting in a chair. When you're sitting in a chair, oh, that was the example I was thinking of. When you're sitting in a chair and you're sitting down and you're pushing down on it with a force of 10 newtons, the floor is pushing up with a force of 10 newtons. So there's no movement. When you're sitting in a chair, there's no movement. And that's exactly what you want. You don't want any motion when you're sitting in a chair. Now, obviously, if you're in a rolling chair, that's a little bit different. But if you're just sitting in a chair, there's no motion. Now, if there's an unbalanced force, it's not balanced at all, you're going to have motion happen here. Okay? And back to that example of the two dogs playing tug of war. Okay? And when they were playing tug of war, you had one pulling more than the other. The force was greater. And because of that force being greater, there was motion in the rope. So you're only going to have motion when the forces are unbalanced. So, motion, here is an example of balanced forces. Every one of these cards has a balanced force on it, which is why they're not moving. They're staying stationary. These are balanced. If they were unbalanced, the cards would be moving and the castle would be collapsing. But in this case, this is balanced, no motion. Now with an unbalanced force, which is what this is an unbalanced force. Because you have the kid here, it's unbalanced, he's kicking the soccer ball, which means the force of his foot kicking the ball is greater than the force of the ground, which is holding the ball. Okay, the ball is just sitting on the ground. The force is greater, causing it to move. Now, eventually, the force of the ground starts to overtake the force of his foot over time, which is why the ball eventually stops. But for a split time, or a short amount of time, the force of him kicking the ball is greater. This is an example of unbalanced because there is motion that occurs. All right, now let's talk about two other forces that are acting on objects. Most of these are acting on unbalanced objects, which is the one we're going to talk about first. But the first one I want to bring up is friction. Friction is a force, and friction is all around us, and sometimes friction is often considered to be bad. It's not bad at all. Friction is bad in motors. This is why we use oil in motors to reduce friction. We don't want parts of metal rubbing up against other parts of metal. But friction is not necessarily bad. And there are three types of friction. Okay, three types of friction. Friction does help us quite a bit. In fact, without friction, we wouldn't be able to stand. Every time we tried to stand, we would actually fall to the ground. But the three types of friction are sliding, rolling, and fluid. Now, there technically is a fourth type of friction, and I'm just going to put this one up here. It's called static. Static friction, okay? And static friction is it's the friction that causes objects to just sit in one place. There is no motion that takes place here in static friction. Okay, no motion at all. It's static. But the three that we're going to talk about primarily are sliding, rolling, and fluid. Okay, let's start off by talking about sliding friction. Sliding friction up here is the friction between objects when they're sliding past one another. For example, if you take your hands and you slap them together and you're rubbing your hands back and forth along one another to warm them up, okay? Like it's really cold winter day and you're sliding your hands back and forth one another to warm them up. That is an example of sliding friction. You're sliding one object past another. Sliding a book across the table, that's sliding friction. The book eventually comes to a stop because the friction between the book and the table, it's resisting motion. Okay? Now, rolling friction is a little bit different, and I'll talk about that here in just a moment. But before we do that, let's talk about fluid friction first, okay? Here we have this wonderful picture of this shark. Nothing fancy, but this is an example of fluid friction. We have one object, okay, swimming around in a liquid, and it doesn't have to be a liquid. It can also be a gas like air, and it is causing it to slow down, okay? The water, you know, it's just much like you. When you get into the pool to go swimming, you do not swim as fast as you run because the fluid friction of the water actually slows you down. Now, this next picture I'm going to show you, you've all seen something very similar to this at one point in time. But this is just a skydiver, nothing fancy, and this is a great example of fluid friction. Now, this example of fluid friction is so special that we actually give it an additional name. This is called air resistance. Okay? Air resistance. Air resistance happens everywhere. Okay? When you're running down the road, you have air resistance. You would actually run faster if you were in a vacuum that had no air versus out there running down the street where there's air. Air resistance, okay? The whole point of a parachute in this example here is to increase air resistance, causing the skydiver to fall safely back down to the ground. Without the parachute, the skydiver does not have enough air resistance in order to slow his fall. The parachute increases his air resistance. It doesn't decrease it, it increases it. Air resistance is what slows the skydiver down. Again, air resistance. Important to know that it's a type of fluid friction, very important, and therefore it gets its own name. Okay. Now, another one I'm going to show you is rolling friction here. And I'll move this off to the side here. Rolling friction is the third type. Okay, and if you look here, there's a block sitting on three cylinders. And cylinders are round, and they can roll around. And it's much easier to actually roll this block on the not three cylinders, four cylinders, sitting on the cylinders than it is to actually slide it. Because when you are actually using rolling friction, the only portion of this block that's actually touching the ground is the portions of the cylinders. That spot, that spot, that spot, and that spot. That is a much lower surface area than the whole block combined. Okay? The whole block is a much greater surface area than those four little tiny dots. So when you're moving large furniture, it's much easier to put it on something that rolls than it is to slide it across the ground. So rolling friction. That's the three types of friction that we're going to spend most of our time dealing with. Sliding, rolling, and fluid friction.